Hi friends, welcome back to the channel and yet another video. So here we have a problem which was asked in GATE 2019, and the problem goes like this. You have a cylindrical rod of diameter 10 mm and length 1 meter, and it is fixed at one end. So this is fixed here. I will use a different color. So this is fixed here like this end it is fixed, and on this end we have applied a torque. This is the end where we have applied a torque. So this is the end where we are fixed, and this end we are applying a torque. I have shown the torque like this, like you have a system straight like this, and you apply a force in this direction at this end, and you apply a force in the opposite direction at the other end. uh, you are asked to find out the maximum shear strain in the road. It's a very interesting problem because I think this is one of those concepts which usually students overlook when reading or when learning about torsion. So here you see this is a bar subjected to torsion, pure torsion. This particular double arrow symbol is usually used to denote the torque acting at a particular point. Then what happens to this small dx element, delta element? It undergoes shear. So if you can see here, initially, let's say before application of torque, this A, B, C, D is the initial configuration. Once torque is applied, your configuration is A, B prime, C prime, D. Okay, so if you take, as you can see over here, ABCD is the initial configuration, and deformed configuration is A, B prime, C prime, D. So there is a definite shear strain as indicated over here. There is an this is the shear strain. Well and good. Now there is a very important relationship between the angle of twist 5 with the shear strain, which is this angle, which can be denoted as gamma. Clear? So now I request you to focus at this element, at this small element. Okay, and this figure, it is as good as if we can focus at this location BB prime. The length of BB prime, if the radius of the road is little r, then that length can be approximated as rd5, because it's this particular portion is the perimeter portion or the circumference portion. So if d5 is in radians, then this distance can be r times little r times d5. This is our bb prime. Well and good. Now if you look at this deformation pattern, or the way how in which this line AB deforms to AB prime, then the same distance BB prime can be denoted as dx times gamma. Make sense? We can equate these two, and then we end up with this very important formula, dx gamma. Make sense? So this is sometimes often not looked in detail when students usually learn torsion. Torsion is a case of pure shear, or that should be understood clearly. Once this is understood clearly, then rest of the things are fairly easy to do, because in this problem we know all the dimensions, because length is 1 meter, radius is 5 mm. Then they are giving you this quantity, the angle of twist at the end of the bar. They are telling that it is equal to 10 degree, but remember, you won't get your circumferential distance. Let's say this is your this was our circumferential distance is equal to bb prime. One condition that I had told is this d5 should be in radians. A quick check: perimeter of the circle is 2 pi times r. Why is it so? Because 2 pi is the angle in radians. This is the angle in radians corresponding to your 360 degrees. So if you want the perimeter or if you want the circumferential distance, then your angle should be always in radians. Okay, so the next obvious thing to do is to convert the 10 degree into radians. Once you do that, then it's a simple plug and check. So gamma is your shear strain, L is the total length of the bar, it is equal to R times 5. Then you have this expression, it tells you this is the amount of shear strain. One thing I would like to tell you is that when you get this type of problems in gate or in gate exam, always pay attention to details like this, because they're not asking you the exact shear strain, they are asking you some factor of it or some modified form of it. So pay attention to what they are asking. They are not asking the shear strain, they are representing your shear strain as some p times 10 to the power minus 3, then they are asking you p. Okay, so it's good you pay attention to all these minute details. Thanks for watching. I will come back with another problem soon. So the key takeaway from this particular video is this, I believe, this figure. So how shear strain of the material is related to the angle of twist, and I think it's good you remember this deformation shape when you apply torque on a cylindrical rod fixed at one end, and when you apply a torque at the other end, how it deforms, how each element deforms. So it's a good figure to keep in mind, I guess. Thanks for watching.